Hey, it's Mr. Donahue again. We're going to take a look at how to name ketones and aldehydes. So the system that you're going to use is first find the longest possible chain of carbons, and this is your base name. Then you're going to number the carbons so that if there's a substituent or a functional group, it's given the lowest possible number. And then you're going to name and give the location of each of those substituent groups. If you got multiple substituents that are the same kind, you're going to use di, tri, tetra, penta, and etc. From when you got 2, 3, 4, 5 of them. If I had 2 chlorines, it'd be dichloro. And then you list them alphabetically. So let's take a look. Ketones. Remember that ketones have the O in the middle. So that's how you know it's a ketone. And then boom. So I know I got a ketone here because on either side of that carbon with the double bond O, there's other carbons. So base and then suffix. So the suffix is going to be -one, just like in the word ketone, right? They don't try to trip you up. It's part of the word ketone. So if the location is ambiguous, you got to use a number to describe where the ketone group is. Sometimes it can only be in one place, and I'll show you those examples. But if it could be in multiple places, you need a number to say where it is. So again, follow the system. Find the longest possible chain. Here it's 1, 2, 3, 4 carbons. Number it to give the smallest possible number. If I go left to right, 1, 2, 3, and 4. And if I go right to left, 1, 2, 3, and 4. So I'm going to want to go left to right. And then name and give its location. All right, well, bute is going to tell me 4 carbons and tells me there's single bond. One is going to tell me that there's that ketone group. And now I got to say where that ketone group is, right? No, because it can only be here. It can only be here if it's a ketone. Well, what if it was right here? Then you number it in the other direction and get the same thing, right? So it's really just butanone. If you put 2-butanone, I'm not going to yell at you. I just, will think less of you or something. I don't know. Just kidding. Or am I? All right, here's another example. CH3CO, CH3. So it's written like this because it's the condensed molecular or structural formula. So boom, boom. It's saying that this is your structure. So what is this? Well, I got 3 carbons, so that tells me it's prop. Single bonded tells me an. Ketone, because it's a double bond O in the middle, on, and it doesn't have to be the exact middle, just I'm saying it's not at the end. All right, so this is propanone. Do I need to put a number? No, because it can only be there. If it was over here on one of those carbons, then it would be an aldehyde and be a different thing. So this is just propanone. What about this molecule? All right, again, find the longest possible carbon chain, which, it could be 1, 2, 3, but you probably know it's not that, right? So I'm going to look for the longest possible chain, which is going to be this way. It could have also gone down this way. It wouldn't make a difference, right? But I like numbering them this way. All right, so now you got to figure out which way you're going to number it. Well, I can tell you right away. I know oxygen, the ketone group, is down on this end, so I'm going to want to number it from this side. So 1, 2, 3, 4, 5, 6. I got 6 carbons, which tells me it's hex, single bonded, and -one ending because it's a ketone, and I got to say where it is. So this is 2-hexanone, and on 2-hexanone, there's a dingly dangly. There's a methyl group, so that's going to be methyl, and I got to say where it is. It's on the 5th carbon, so 5-methyl-2-hexanone would be the name for this molecule. All right. How about we draw one? I got 3 pentanone. So pent tells me I got 5 carbons. And tells me they're all single bond. One tells me there's a double bonded O. And where is it? It's on the 3rd carbon. So 1, 2, 3. There's a double bond O here. And then I fill in all the oxygens for the rest of them, completing the octet. And that's 3-pentanone. Okay, aldehydes are pretty much the same thing, except just very slightly different. So base and then suffix. The suffix is al, as in aldehyde, and al is at the end of the word, right? So that's how you know it's an aldehyde. You got the double bond O at the end. Whoops. All right, so let's name them. All right, so we got find the longest chain, 1, 2, 3, 4. All right, that's a carbon, carbon, carbon. So 4 carbons tells me that it's bute. Single bonded tells me and this aldehyde right here, because I got the C double bond O on a carbon that has an H, tells me that it's going to be butanal. Grow up. All right, do I need a number on this? No, because all aldehydes have the double bond O on a terminal carbon, so you don't have to specify. We know it's on that end. All right, this one 1 carbon, Easy, meth and al, because it's an aldehyde. Carbon has a hydrogen on it with the double bond O, so it's methanal. What about this one? Well, all right, I got 1, 2, 3, 4, 5 carbons, so that tells me it's pent. And single bond N and an aldehyde group tells me al, so pentanal. Don't need a number for that one. All right, how do I draw heptanal? Well, hept tells me that there's 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And I know that there's going to be a double bond O on an end carbon. So I can do this. And if I'm feeling crazy, I can also do this. Right? That's heptanal right there. So that's ketones and aldehydes. Hope you found that helpful. I'll see you in class.